All right, I just want to do a quick run through for example 6. So we've got this clock. We know that minute hand is 8 minutes long, and the center of the clock is 120 inches above the ground. So there's 120. I know the top, then if it's 8 inches long for the minute hand, that'd be 128, and the bottom would be 8 inches below 120, so that'd be 112. Okay, we're told at t equals 0, we're at the top, and also at t equals 30. So in part A, I'm supposed to model those 5 points here. We've got a function modeling the height between the endpoint of the minute hand from the floor as a function of time. So determining the possible coordinates here, I know the top would be a height of 128, and the bottom would be a height of 112. 120 is the midline. And I know that we're starting at t equals 0 at the top, so f could be 0, comma 128, and it returns to the top 30 seconds later, so p would also be a height of 128, but that would be time 30. J is halfway between, so that would be a time of 15, and it's at the bottom halfway between, so that'd be 112. G is halfway between 0 and 15, so that would be 7.5, comma 120, and K, another 7.5 seconds after 15, so 22.5, comma 120. Referring to that graph in part A, the t-coordinate of G is T1, and the t-coordinate of J is T2. On the interval T1 to T2, so it's giving us that's T1 and that's T2 right there. You can't see the J anymore, but it's there. Which of the following is true about H? H is positive and increasing, H is positive and decreasing, negative increasing, negative decreasing. H is the function of the height. Well, the heights are all positive, 128, 120, 112. So the function itself is positive, and the function itself is decreasing. It's going from 120 to 112, so that's B. How the rate of change is changing. So that's our concavity, right? The rate of change of the rate of change. And so since we are concave up here, we would say the rate of change is increasing because H is concave up on T1 to T2.